Okay, so what are we doing here? If we want to solve this from a non-geometric perspective, the main goal, again, is to minimize those errors. And so I'm going to write this out as minimizing the sum of the squared errors. So the sum of epsilon I squared is going to be equal to epsilon transpose epsilon if we were to write this in matrix form, which is equal to y minus x beta transpose times y minus x beta. So this is in matrix form, the thing that we're trying to minimize. So what we're going to do is we're just going to take the derivative of this and set it equal to 0 and try to find that beta hat that satisfies it. So if I take the derivative of this and set it equal to 0, I end up with x transpose x beta equals x transpose y. And so now let's solve for beta. And these are called normal equations. We can derive the same result using the geometric approach, but let's solve for this. So given that x transpose x is invertible, this is an important point here, x transpose x must be invertible, but if it is, then I can move this over to this side of the equation. I have beta hat equals x transpose x inverse x transpose y. Beta hat equals x transpose x inverse x transpose y. So that should look familiar. That's what you all did in your lab the other day. You solved this using the x that you pulled from that polymer penguins data. Okay, so now if we wanted to get x beta, we would just add an x to the front of this. So x times x transpose x inverse x transpose y. And this should look familiar because this is that thing that we are trying to get at, that y hat that we're interested in. That's our predicted value for y. And so what that means is that this part right here, x times x transpose x inverse x transpose y, that is that H matrix that we were talking about, that optimal orthogonal projection, or the hat matrix. We call this a hat matrix because when you multiply y by it, it puts a hat on it. So this hat matrix is the orthogonal projection of y onto the space spanned by x. So that's exactly what we showed in the geometric version, but this is just kind of how it works out when you do the derivative. So the predicted values that we're interested in, this y hat here, we can, as shorthand, we can just write this as hy.